Why do you need 3
It's better from a
Okay,
teacher.
the muscle fiber is a bundle of fibrils. This is where you're going to find the nuclei, all right? And it is surrounded by the sarcolemma. Well, this is fiber actually, not this one. We're too far out. Okay. No, this is sarcolemma. Zoomed in. The sarcolemma. The sarcolemma is an electrically excitable membrane. It's just a membrane that you can send electricity through. Okay? Between your fibrils, you're going to find all the mitochondria. You know you need a lot of mitochondria because you need a lot of energy. It's also why you need a lot of blood flow. So you should find also lots of capillaries. They're not listed on here. Okay. Now, your light I band. The I band is in between the sarcomeres. The I band is in between the sarcomeres. It has the Z line, which is where the sarcomeres are zipped together. Okay? In the center of your sarcomere, in the big A band, which is dark because it's the sarcomere, it's got where all the fibers are, you'll find the H zone. In the center of the H zone is the M line. The M line is the middle of the sarcomere, and it's where the myosin attaches. The myosin attaches to the M line. The actin, which is the thin fiber, connects to the Z disc. The actin connects to the Z disc. It connects A to Z. The sarcoplasmic reticulum is the electrical fibers that come down from the sarcolemma. You'll see later that when you electrically excite the sarcolemma, it releases calcium from the sarcoplasmic reticulum. That calcium, if you remember, I'm just going to go really fast. That calcium is going to bind to your tropomyosin, which is covering the binding sites for your myosin heads. So the calcium is released all along my brain is not working. All along the fiber, the calcium is released at the same time. So all the tropomyosin moves at the same time. All the myosin heads that are aligned to those binding sites can grab onto the actin and pull, making the myosin and actin overlap. Nothing shortens, they overlap, contracting the muscle fiber all along the fiber, all at once. In order to release that myosin head from the actin fiber, you need ATP. ATP will come in, bind to the head, it will release from the actin. The myosin head will use the ATP, turning it into ADP, adenosine diphosphates. We've lost the phosphate. It will change shape. Once it kicks out the ADP, it's ready to grab on again. Whee! And the cycle starts over and over. They grab on the myosin heads at different times. That way, they're not going up a rope and letting go of both hands at the same time. They're going to do one at a time, several myosin heads at a time, until it's full contraction. The reason that you have rigor mortis after you die is because you're no longer making ATP, but you still have calcium in your tissues. So rigor mortis is after you die, your muscles for a short period of time, about an hour or two, will lock up. They'll all contract, okay? That's because you still have calcium ions, so they're going to still open up the tropomyosin. The muscles are still going to contract, but you're not making mitochondria. Your mitochondria aren't working. They're not making ATP, so there's no ATP to release them. Until finally your body is starting to degenerate. It's done with free calcium, and your body relaxes again. Thank you.
Thank you.